Hello, my name is Marta and I will explain arithmetic sequences. And an arithmetic sequence is a sequence in which you always add the same number to get to the next term. So, for example, it's 3, 7, 11, 15, and so on. So the rule is add 4. That's the rule. To get to the next term, you add 4, add 4, add 4. That's the rule. To get the next term, I will add 4. Of course, you can add negative numbers as well, and then you will have, for example, 20, 15, 10, 5, and so on. And now it's still an arithmetic sequence. The rule is add minus 5. Add minus 5, add minus 5, add minus 5. So this is also an arithmetic sequence. But this number that you add has to be the same each time. So, for example, if you have 3 and then 4 and then 7 and then 10, that means that I have to add 1 and then add 3 and then add 3. So that's not an arithmetic sequence because the number you have to add to get to the next term is not constant. It's not always the same. Okay, and now if you deal with this special arithmetic sequence, there are two components which define it. Well, first of all, I have to know what term I start with. So what is the first term? For example, in here, the first term is 3. I will denote it as U1. And here, the first term is 20. The second thing is the number that you add. So the first term, to define an arithmetic sequence, you have to know what is the first term, and then the number that you add is called the common difference. The common difference, and it is denoted by D. So in here, in this sequence, the common difference is 4, and in this sequence, the common difference is minus 5. Okay, and then if you always add to get to the next term, you know that you're dealing with an arithmetic sequence called also an arithmetic progression and denoted as AP for short. Okay, and if you have an arithmetic sequence, you can give its general formula, which will always look like this. Un is U1 plus n minus 1 d. This formula is just the result of how the arithmetic sequence is constructed. The first term is U1, then the second term is U1 plus d. The third term is U1 plus 2d. The fourth term is U1 plus 3d. So the rule is that to create the fourth term, I have to get U1 and add 3 differences. To create the third term, I take U1 and add 2 differences. To get second term, U2, you take U1 and you add 1 difference. So basically always 1 less than the number of term. So following this method, to create the nth term, I have to take the U1, the first one, and add how many differences? Well, following this method, I can see that I have to take n minus 1 differences. So I can use this formula, this general formula, if I deal with arithmetic sequences. If I want to find the formula for an arithmetic sequence, I can just use this recipe. So let's take the first one, 3, 7, 11, and so on. I know here that the first term is 3, and the common difference is 4. So now if I want to give the formula for the nth term, I know that I just have to follow the recipe. The nth term is the first term plus n minus 1 differences. Of course, I can simplify this formula, expand the brackets, and I get 3 plus 4n minus 4, so 4n minus 1. That's the formula for of this first example of this first sequence that we had here. Okay, so let's use what we learned in examples. Let's take a look at the first example. Find the nth term of the arithmetic sequence 6, 20, 34, 48, 62. Find which term is the first one to exceed 100. Okay, so in here I will copy this sequence. It's 6, 20, 34, 48, 62, and so on. And I would like to find the nth term, so just a formula. So un is what? I have to find the formula. Okay, I know that it will be the first term plus n minus 1 differences. That's what we learned. So let's try. u1, the first term, is 6. The common difference, d, I can see that it is 14. d is 14, so I can write down the formula. un is 6 plus n minus 1 times d, which is 14. I can simplify this formula, and I will have 6 plus 14 and minus 14, which is basically 14 and minus 8. That's the formula for the nth term. Why do we need this formula? Well, if you have the formula, now if you want to find the, say, 100th term, which we didn't have to do in this exercise, but I just want to show you how to find the 100th term. If we didn't have this formula and we just wanted to add 14 till we get to the 100th term, that would take ages. Because the 100th, this is the first one, this is the second one, the third one, the fourth one, the fifth one. Now I have to repeat until I get to the number 100, U100, so the 100th term. But if I have the formula, I can just substitute 100 for n, and this way I have the answer very quickly. The 100th term, so the one that it is the 100th number, is 1392. So this is why we would want to find the formula. It's pretty handy. But now we have to find which term is the first one to exceed 100. So now we are asking which term, and is unknown, exceeds 100, is more than 100. Okay, let's try. I know that any term, the nth term, is given by the formula 14n minus 8. So basically, I am asking when 14n minus 8 is bigger than 100. Okay, so let's try to solve this inequality. 14 minus n is bigger than 100. So that means that 14n is bigger than 108. So that means that n has to be bigger than, let's check, 108 divided by 14, 7.7 approximately. Okay, so the one after the seventh one, which is 8th. Okay, well, you can't have the n equal to 7.7 because n means the number of term, and the terms are the 6th one, the 7th one, and then the next one is the 8th one. So if I know that it is after 7, that means that the 8th term is more than 100. Let me show you on calculations to make sense of it. If let's calculate using the formula. Let's calculate U7. U7 is 14 times 7 minus 8. That's the formula, right? It is always 14 and minus 8. So 14 times 7 minus 8 is 90. So the 7th term is 90. And that is less than 100. But the 8th term, it's 14 times 8 minus 8. The 8th term, let me calculate, 14 times 8 minus 8 is 104. So now you can clearly see that the 7th term is 90, that is smaller than 100. The 8th term is 104, that is bigger than 100. So the first term, which is bigger than 100, is the 8th term. Okay, let's try to look at the next example. Find the first term and the common ratio, common difference. I'm already ahead in the geometric sequences. Okay, common difference of an arithmetic sequence. If you know that the third term is 5 and the 8th term is 20. Let's try. How will we solve it? How will we approach it? I think we could use the general formula. Substitute what we have, form a system of equations and solve. But let me show you a trick, because I think a lot of students actually understand the trick and it's really a nice, neat way to solve it. Look, let's just use logic. If I have the third term, right, then to get to the 8th term, I have to add differences a few times. And let's count how many times. Okay, to get to U4, I have to add the difference, right, the common difference. To get to U5, that's how I jump to the next term in an arithmetic sequence. I just add the difference. I don't know what the difference is. That's what we have to find. But I know that if I add to the third term, if I add 1, 2, 3, 4, 5 differences, I will get the 8th term, which is 20, right? The 8th term is the third term plus 5 differences. The first term plus 5 differences would be the 6th term, but the third term plus 5 differences is the 8th term. So I'll erase this formula because that's not what I am showing right now. Okay, and let's just focus on this method. So to get from the 10th term, if I add to the 10th term 7 differences, I will be at the 17th term, and so on. So that's what I will use here. U3 plus 5 differences is U8. U3 and U8 are given. So I can find the common difference. The common difference is 3. There you go. The common difference is 3. And you can solve a lot of problems using this method. Just count how many differences you have to add to the first term to get to the next one. To the next in the exercise. How many differences? Okay, and that would be the common difference. It is given. Now we have to find the first term. Okay, so again, the first term, since we have the third one, we will create by adding the difference 2 times. U1 plus 2 differences would be U3. So, and since U3 is given, U3 is 5, and D is well, we found D, it's 3, we can calculate U1. U1 is 5 minus 2 times 3, so minus 1. And that's it, that's the first term. So basically we got the common difference and the first term just by using the relation in an arithmetic sequence, just by using the fact that to get from one term to the other I always have to add a certain number of common differences. Okay, so this is my answer, and I will just write it down. Well, not this marker, it's not visible. Let's use pink. Oh. So u1 is minus 1 and the common difference is 3. If you were asked to find the general formula, a formula for this sequence, you would just substitute to the formula that you know. The formula for an arithmetic sequence is un is u1 plus n minus 1d. So in our case we just substitute u1 is minus 1 plus n minus 1 and d is 3. And then obviously I will try to simplify it just to make it nicer. Expand the brackets, 3n minus 3 and minus 1, so 3n minus 4. That's the general formula for this arithmetic sequence. Having this formula now, you can find 100th term or any term you want. Let's take a look at the next example. Okay, calculate the number of terms in the following arithmetic sequence. So we have the sequence given, but it is finite. We have to find out how many terms are there. And obviously I will try to avoid listing all the terms because that would be too time consuming. Let's try to avoid that. So what do we have? I have the first term. The first term is 90. We have the last term in this sequence, but I don't know which one it is, and it's unknown, but I know it's 14. So basically I just want to find out how many times I jumped from 90 to 14 in this sequence. And I know the difference, the common difference is minus 2. Right? To get from 90 to 88 I have to subtract 2, subtract 2, subtract 2. So that's what I'm doing here. The common difference is minus 2, negative 2. Okay, and well, I know that the formula is u1 is, what am I doing? Not u1, un, the formula. I want to use the formula. The formula is un is u1 plus n minus 1d. And I don't know, I could just try to figure out n by calculating how many times I had to jump from 90 to 14, but I think I would just be straightforward here and I would just substitute what I have to this formula. I have u1, u1 is 90. I have d, the common difference here is minus 2. I don't know n is unknown because this is what I have to find. I don't know how many, which term it is, so I will just write n minus 1. And un stands for this term, the value, the number, and it's, I don't know which term it is, but I know that this term is 14. That's basically what I'm doing here. Okay, this term is 14. But I don't know which one it is, but I will know if I find n, if that makes sense. Okay, so basically if we just substitute everything we have here to this formula, we will find n, which was the task, because the question is asking how many terms are there in this sequence. Okay, let's try. 14 equals 90 minus 2n plus 2, so 2n is equal to 92 minus 14, and 92 minus 14 divided by 2 is 39. So there are 39 terms. This term is U39. I think that's the important thing here, to realize that this number n tells you which term in the sequence it is. Is it the fourth one, or is it the term number 39, which is in position 39? But this number tells you how much it is. So it is the term number 39 in the sequence. It takes the position number 39, but it is equal to the 39th number is 14. And in this question we had to realize which one is which. What is important in this lesson is to remember to learn by heart how the arithmetic sequence works. In an arithmetic sequence, the important thing is that we jump around by adding d. To get to the second term, I add 1d. To get to the third term, I add 2d. So to get to the nth term, I add n minus 1 differences. So in general, un, the nth term, is our u1 when we started, plus n minus 1 differences. And that is the key. That is the key. If we remember this formula, everything will be fine. That's all I wanted to say about arithmetic sequences. See you in the next video.